a lot of what we've been dealing with first derivative tests and second derivative tests, finding mins and maxes, concavity, all that stuff, what it's really leading to is the idea of being able to graph functions. So here's a learning objective, what we're going to be covering over this next couple of videos. I want to be able to analyze and sketch a curve of a function. That's the key thing here. So everything we've learned regarding the first derivative and second derivative tells us about the behavior of a function, along with the vertical asymptotes and the end behavior, can easily be combined to help us produce meaningful graphs of functions. Now, the following is a basic strategy for sketching graphs. Number one, I want to identify the domain or the interval of interest. I want to locate all intercepts, making reference to the x and y intercepts. I want to find the first and second derivatives and use them to identify local mins and maxes, along with the concavity and inflection points. And then I need to identify all asymptotic behavior, which means vertical asymptotes, and the end behavior, horizontal asymptotes. So once I do all of that, essentially all I'm going to do is put it together, piece the thing together, and I get a good idea of what this graph is going to look like, what the function of graph will look like. So before I do a real example, let's jump into kind of the results of an example. I may have a situation where I know that for x less than -1, the first derivative is negative and the second derivative is negative. So what does that tell me about my function for less than -1? Well, the first derivative is negative. That means I'm decreasing, so I'll be decreasing. But the second derivative is negative, so that means I must be concave down. So I'm concave down and decreasing up to x equals -1. Now, from -1 to 2, from -1 to 2, I know that the first derivative is still negative, so still decreasing, and the second derivative is now positive. So I switch to concave up, but the first derivative is still negative. So I'm concave up, but the slopes is still negative. Now at 2, between 2 and 8, the first derivative switches and becomes positive, and the second derivative continues to be positive. So if it's continuing to be positive, that means I'm still concave up. And I'm switched from negative to positive on the first derivative, so I have a local min. And that is between 2 and 8. So I'm coming back up. Now at 8, the first derivative continues to be positive, but the second derivative becomes negative. The second derivative switches signs. So I have another change in concavity from 8 to 10. And then at 10, my first derivative still continues to be positive, but my second derivative changes sign, so I have an inflection point here, and I become concave up. So I'm concave down, concave up, concave down, concave up with all these inflection points. Now, these intercepts here, there's no need. There's no need for these specifically. I had no intercept information. I could just easily take this entire graph and shifted it up. Doesn't matter where I shift it up or down. I know that I'm going to get this sort of a thing going on with the graph. I know exactly what's going on with the graph of this function. I just made these intercepts here because it made it easy, as I was talking about 1, 2, and 8. It made it easy to visualize. But like I said, there's nothing here. There's no evidence, no information given that tells me that these are the actual intercepts. They were just simply convenient for me to graph this thing with.